Basics of electric current and Coulomb's law. Detailed description. The image explains the basics of electric current and Coulomb's law, two of the most important concepts in electricity and electronics. Electric current is the flow of electric charge through a conductor, while Coulomb's law explains the electrical force between two stationary electric charges. Although both concepts involve electric charges, they describe different phenomena. Electric current deals with moving charges, whereas Coulomb's law describes the force between charges that are not moving. Understanding both concepts helps explain how electricity works in electrical circuits and why charged objects attract or repel each other. The left side of the image explains electric current. Electric current, represented by the symbol I, is defined as the rate at which electric charge flows through a conductor. Its C unit is the ampere, A, where 1 ampere means 1 coulomb of charge passes through a conductor every second. 1 A is equal to 1 CS. Current flows when a voltage source, such as a battery or power supply, creates a potential difference that pushes electrons through a conducting material. The direction of conventional current is considered to be from the positive terminal to the negative terminal, while the actual electrons move in the opposite direction. The image also shows that current can exist in two forms: direct current DC and alternating current AC. The image describes direct current DC as a type of current whose magnitude and direction remain constant over time. The waveform is shown as a straight horizontal line because the voltage and current do not change direction. Batteries, solar panels, USB power supplies, and mobile phone batteries are common sources of DC current. Since the voltage remains nearly constant, DC is widely used in electronic circuits, computers, mobile phones, LED lighting, and battery-operated devices. In contrast, alternating current, AC, continuously changes both its magnitude and direction, producing a sinusoidal waveform. AC is generated in power stations and supplied to homes through the electrical grid. The image highlights important AC waveform terms such as peak current, IP, frequency, F, and period, T, which describe how the current changes over time. Household electricity typically operates at 50 Hz or 60 Hz, depending on the country. The right side of the image introduces Coulomb's law, which explains the force between two electrically charged objects. According to Coulomb's law, the force between two charges depends on the amount of charge on each object and the distance between them. The mathematical formula is F is equal to K times vertical bar Q times Q vertical bar R superscript 2, where F is the electrostatic force measured in newtons, N, Q and Q are the electric charges measured in coulombs, C, R is the distance between the charges measured in meters, M, and K is Coulomb's constant, approximately 8.99 times 10 n.m superscript 2 C superscript 2. The law states that if the charges are larger, the force becomes stronger, and if the distance between the charges increases, the force becomes weaker because it decreases with the square of the distance. Coulomb's law also explains the behavior of positive and negative charges. Like charges, positive or negative, repel each other, pushing away from one another. Unlike charges, positive-negative, attract each other, pulling toward one another. This attractive and repulsive force is the reason why static electricity occurs and why charged particles interact inside atoms and electrical devices. The force exists even when the charges are not moving, making Coulomb's law one of the fundamental laws of electrostatics. The image provides a practical example of static electricity. Imagine a person walking on a carpet during dry weather. As the shoes rub against the carpet, electrons transfer from one surface to the other, causing the person's body to become electrically charged. When the person touches a metal door handle, the stored electric charge suddenly flows to the metal, producing a small electric spark. This spark is caused by the electrostatic force described by Coulomb's law. The image also compares this small static discharge with lightning, which is a much larger electrostatic discharge between clouds or between a cloud and the ground. In both cases, opposite charges attract each other, and when the electric field becomes strong enough, a sudden discharge occurs. A simple numerical example helps explain Coulomb's law. Suppose two small charged objects have charges of plus 2 microcoulombs, μc, and 3 microcoulombs, μc, and they are placed 0.5 meters apart. Since one charge is positive and the other is negative, they attract each other. According to Coulomb's law, increasing either charge would increase the attractive force, while moving the charges farther apart would reduce the force significantly because the force decreases with the square of the distance. Although the exact calculation depends on the formula, this example demonstrates how both charge and distance affect the electrostatic force. A practical example of electric current is a battery-powered flashlight. When the switch is turned on, the battery provides a voltage that pushes electrons through the wires and LED bulb. The moving electrons create an electric current, and the LED converts electrical energy into light. Here, electricity is flowing continuously through the circuit, which is different from static electricity where charges remain at rest until they suddenly discharge. A simple way to understand the difference between electric current and Coulomb's law is to compare them with water. Electric current is like water flowing through a pipe, where the water moves continuously from one place to another. Coulomb's law is like two magnets interacting without touching. Depending on their poles, the magnets either attract or repel each other. Similarly, electric charges can attract or repel each other even when they are not moving. In summary, the image explains that electric current is the continuous movement of electric charge through a conductor and is measured in amperes A. Current may be direct current, DC, which flows in one direction, or alternating current, AC, which changes direction periodically. Coulomb's law, on the other hand, describes the electrostatic force between two stationary electric charges. It states that the force increases with larger charges and decreases rapidly as the distance between the charges increases. Together, these concepts form the foundation of electricity, electronics, electrical engineering, and electromagnetism, helping us understand everything from simple battery-operated devices and household wiring to static electricity, lightning, and the behavior of charged particles inside atoms.